Hello, sir. I'm Shivansh, and today I'll be presenting my course project presentation for the course of Privacy and Information Security. I'm presenting PyChain. It is basically a simplified blockchain model built using Django and React. This project is designed to demonstrate the fundamentals of blockchain and including the mining, proof of work, and the consensus across the nodes along with transactional handling, all in a React based web interface. So basically, what is PyChain? So PyChain is basically it is based on a proof of work algorithm, and it mimics how real world blockchains like Ethereum, Bitcoin, they ensure data integrity and decentralization. Each block contains a transaction and is linked to the previous one through a hash function. So I've also implemented a mini network mechanism so multiple nodes can sync their chains via consensus. So what is basically proof of work algorithm? So basically we start with the nonce which has a value of 1, and then we calculate the SHA hash value of the squared distance between the nonce of the current block and the previous block, and we check the first four characters of those hash function, and if they are not 0000, first four characters are not 0, then we increment by 1, and again we repeat the process. But if the first four characters are 0, then the condition is satisfied, and this value of the nonce will be used for the next block. And I've implemented API endpoints basically with the functions which I've implemented, and the steps basically. So I'll show you the core logic of my program. So uh, basically the method of proof of work is being implemented over here. So throughout this code is basically what we have done. So as I've mentioned, if the hash function first two characters are 00, the condition is satisfied. If not, then we increment it. So basically what I have done is I've created a class of blockchain, and I've initialized it. Then I've created the blocks with the following values: index, timestamp, nonce, previous hash, transaction, get last block. These are the various functions that I've implemented, and I've also implemented that like in real life blockchain, multiple connections can be in parallel, and only the longest chain will be considered. So is the chain valid? The correct nonce is being followed across the blocks. Replace chain, which the longest chain will be considered. That function I've created here. So basically a block function, and also I've created a create block function over here, which appends the new block to the chain, and I can show you the transaction as well. And so basically this method is that it lets any user to add a transaction when the block is being mined using the mine block function, which I'll show you uh, in other over here, and a reward transaction is automatically added to the miner. So if let me show you how it's being run over here. So basically what I've done over here is that I've killed the process on. Basically my backend will be running on the port 8000 over here, and the front end, the React packet will be running on the 3000 port. So every time what I used to do when I was testing it, so process which weren't killed properly on those ports, they caused some issue. So I've created this one file only, which I've when I'm running it, so my both backend and front end gets called equally at the same time while killing the previous process. So I'll show you the processes that I have told you. So my front end is currently, wait 1 second, let me run it over here. It's not working over. Oh, probably yeah. So if I go in my, I'll have to start this in my front end part. So the server is starting. Yeah, so the server is started. So basically I can show you how the current process is going on. So initially, as I've mentioned in the proof of work algorithm, the nonce is one. And now I want to add a new. Let's say I want to create a new transaction. So let's say this sender is Alice, the receiver is Bob, and the amount is left to transfer is, let's say, $10,000. So I've added this transaction. The transaction will be added to block 2. Now this is the transaction that is pending. Now I'll have to mine a block. So when I mine a block, my new block has been mined to my chain, and my the following date, time, nonce, all these things are being shown over here. So like, let's say I'll show another one. Let's say now we have to send from Bob to, let's say, Max, and I have to send around, let's say, another, let's say, $1,500, $1,200. I'll add a transaction, I'll mine a new block, and this is being over transferred over here. Now as we can see, the values from this same nonce is being carried over here, and the nonce values have been calculated, all the details are over here, and I can mine a new block without having to explicitly mention a new transaction. So like, simply mining a new block, I can keep on appending over here. It doesn't matter, my chain will continue, and all the previous nonce value will be carried over. And let's say I want to mention all good, the blockchain is valid, my chain is being valid because all the nonce values again get verified over here, right? Now if, let's say, I want to connect a new node, right? So if I want to connect a new node over here, let's say I'll go to my original directory, I'll create a new terminal, be running on the parallel connection. So let's say I'll simply put this run server, and on the port, let's say 8001. So this will run the code for this, will basically run this, and now I'll copy this and in my application, now I'll connect to a new node, right? Basically this is a text bar, and I can enter anything over it. So let's say I'll connect over here, and I can simply say connect, and my code is saying node connected. So I have my the React application is also showing that a node has been connected. This is a private chain. Now I can again create a new transaction over here. Let's say from Max I want to send to some any guy. Let's say Bobby, and I have to enter any amount. Let's say $1,500, $15,000. Let's say. Now transaction valid. I mine a new block, and my transaction has been added to this. So this is how my I've created. Let's say I have an option of chain replacing the chain as well. So if I say the replace chain, all good, the chain is the largest one. So obviously I haven't created any, like the previous chain had so many transactions, and this one just had one. So obviously this will not be showing it. And just to show this another time, I can simply create a new one, and then I'll run this one more time for you. Copy path, cd, I'll go in that particular directory, PyChain. I can simply run this. Let's say Python, and I'll change the port. I'll change it to 8002. And so another of my one of my parallel is chain is working. I'll copy the path. I'll simply connect this over here. Connect. This chain is connected. My node has been updated over here. Simple. These are the chains, how it's being propagated over here, and I'll show you my manage.py. What it does is, this is basically the main calling function over here. So all of my Django settings of this is the backend is being called from here. All the errors that have been fail safes I have introduced. This is my front end over here, and my I'll show you my dashboard which was in here. Yeah, these are my app.js. All the components of my web page. These are the components. The add transaction one over here. The blockchain, how the chain is being connected over here. The dashboard with the following features and the template layout. Mine block, this function that is being used over here, And then these are the following rest of the JavaScript uh, files over here. So that was it from my side. I hope my presentation was good and you enjoyed, sir. Thank you.